Hi, welcome. My name is Sean Hogston. I'm with Ruckus, and I'm going to be talking about our AI RRM, so radio resource management, some of the comparisons between an AI-based RRM to a legacy, we'll call it, right? So whether that was our channel fly or any other vendor that's out there that does a typical, radio resource management type of function. So in this slide, we're just showing what's typically happening today. So you're normally setting access point channels in some type of non-overlapping fashion, and then see how that works. If you have interference, you'll make a change, see how that works, same kind of thing. The problem with this method is you can see here, you get into this kind of perpetual loop. You make a change in one, it affects the next one, so you make a change there, and you're just in this constant, for our analogy, I guess, chasing your tail, right, around trying to find the right set of channels that work. So what we've done for a next generation of that is we've added the machine learning and the AI-driven power to do the radio resource management. And what that does here is it creates a graph, and I'll show that here in a second, of what the network looks like to AI, to the system that's learning everything. So it will build this graph, and then it's going to start to look at, how will these channels interact. It'll make a digital twin of your entire network, so whether you have 5 APs or whether you have 500 APs, it'll graph this out, make a digital twin of that, and then it will just constantly run different scenarios of changing channels and changing bandwidth, and we'll talk about that a little bit. That's the big controversial piece of it. But it will make all those changes and see what is this going to do to the network when I make this change, right? It will then kind of look at that, learn, make adjustments, and then present that to you to approve it or not approve it. So it doesn't do it automatically unless you say, yeah, go for it, right? And then what it will do is once you make that change, you say, okay, go ahead and make these changes. I think we're gonna be good. It'll then monitor that for 7 days. And if it doesn't meet the performance requirements that you set, it'll roll that back, right? Or it may say, okay, now I need to make another change. So it will just continue to monitor that type of stuff as you go through. So what it initially looks like is this type of graph. And what you have here is the little orange circles are representing an access point. And then all the lines in between them are representing one AP hearing another AP. So it's basically graphing out not just the access points, but all the access points that can hear which other access points. They will map that out. This particular graph was from a trial that we did with a middle school with just 24 APs. So, it wasn't a huge, large network like the next one. This one is what you'll see in our interface. You'll see on the left-hand side, you'll see these red APs and the red link. So this is where AI says, these are interfering. This is what I'm seeing today. So as soon as you spin the network up within a day, you'll start to get these recommendations. And it will tell you all these access points, everything that's red and every link that's red has some kind of co-channel interference. So they're interfering with somebody else. And if you let me make the change and implement what I want to implement, I'm going to give you what's on the right-hand side. Now, in this particular example, zero interference, right? So you've got no more channel interference. In most cases, you'll get close to that. You won't always get zero. That's going to be dependent on the number of APs and all that kind of stuff, what parameters you set for it to do. But in a lot of cases, you can get down to virtually no interference between your access points by letting it do that. And then, like I said before, if you let it run that, it will make those changes, and then it will start to monitor it. So the big advantage of the AI-driven RRM is, unlike your traditional system, we'll make those recommendations. We're gonna let you schedule that stuff when you wanna make that change. We're gonna watch it and monitor it to make sure it's doing what it's supposed to do, and then we've got reversion capabilities to roll it back if it doesn't work. Right, so that's a big difference than the old system where you just make a change, see what happens. If it doesn't work, call me tomorrow, let me know. You're still having a problem. Then you make another change and go along that way. So I threw in a couple just kind of slides here that was looking about a little bit of the enhancements that you get, we'll say. So in this one, we're looking at airtime utilization, the amount of airtime utilization in what we call legacy. I put legacy model here because this could be, like I said, it could be RRM, it could be any vendors, but your traditional selection. So here you're looking at the amount of airtime utilization in the legacy model, and then once you make the change that it recommended, the amount of airtime utilization, and then here we're looking at, and on average, a 65% freeing up airspace and a max of 75. So the other piece of this, and the thing that is, in my mind, the most interesting is the fact that we can let it set different channel bandwidths on different APs. So historically, that's not something we've ever done. You're either running 20 megahertz wide channels, you're running 40 megahertz wide channels, whatever. But now you can let it select different bandwidths. So you may have APs, this AP is on 20, and this one's on 40, this one's on 80. And what we did was, Jim Palmer actually, that you guys are probably very familiar with, did some testing in one of our offices and validated this stuff, and we found that this works, and it increases your optimization, increases all of your performance as long as you don't do more than one step in the jump. So you don't want to have an AP running 20 megahertz wide channels next to an AP having 80 megahertz wide channels, because the clients won't roam when they have to step up twice, right? So the AI RRM will take that into account so that it doesn't put, it'll put a 40 and then it'll have an 80 on this side and maybe a 20 on this side. So you've got a step to be able to roam through. And then the other things that it'll take into account is the power increases. So you're adjusting transmit power, in a 2040 scenario, you want to increase by 1 dB. And if it's a 4080, then power should be increased by 2. So the AI RRM will take all that stuff into account and make those adjustments, as needed, and then try to give you that best performance capabilities out there. So I think that's probably the biggest still kind of mystery that's out there, and the thing that we haven't had a lot of exposure to people being willing to do that, right? But it's definitely something that you can try, and the system will tell you if you've met those performance requirements or not, and roll it back for you automatically. So give in, let it take over, and let it set. let it go, and run its thing, and you'll be surprised at the difference. So thank you.